Hello friends, how have you been? I hope you have been okay. That's a great news. Let's get started our today's lesson. The previous mathematics lesson we studied about just power. We were having a simple introduction to it, but in this lesson we're going to cover the first law of the power. Actually, I've written here laws of power. What? Actually, we're having a few laws. If you want to work with power, you shouldn't have to be aware of them. And I'm just going to start with the first one, really much important one. And that is, look at here, I have written here, first. This is the first law, okay? First law of the power. If we have same bases but different or same exponent, we take one of the bases and add up the exponents. I haven't written here. This is just for this. This law works for the product, okay? While we're doing products or multiplication. In case of multiplication, okay, if we have same bases but different or same exponents, we are just taking the common base, just in only one base, and we're adding the exponent to each other. So here, general form that I have written here for you is a to the power m multiplied by, here, product, okay, multiplication, multiplied by a to the power m. We're having same base, which is a, same exponents, okay, different or same exponents. So here equals, we're having just and only one common base, which is a. Here I have written. Then adding up the exponent a to the power m plus m. Or if we have the same bases but different exponents, we're doing work the same as in this case. A to the power m plus n. I hope you got it, but here I've written some examples. We will do much more examples and you will learn this law completely. Here, look at here. The first example I have written here, a to the power 20 multiplied by a to the power 30. If you think, if we have the same base, don't we? Of course we have. A. The base is the same. What we should do, just and only take one base, a, then add up the two exponents, okay, which is 20 and 30. A to the power 20 plus 30 equals a to the power 50. If you simplify this one and this one, you will get this one, a to the power 50. Okay, we have equality, both this equals this part equals this part. The second example I have written, b to the power 30 multiplied b to the power, here, a could be anything. Base could be anything, could be 2, could be -2, could be c, could be d, could be z, anything you want to write, you can. So b to the power 30 multiplied b to the power -2 multiplied b to the power 3. So what we should do, sorry, b, we shouldn't have to write here b, okay, because we have b there. Yeah, what we should do, we are having same base, okay, taking just and only one common, which is b, adding up the exponents, b to the power 30 plus -2 plus 3, 30 plus -2 plus 3, b to the power 30 plus into minus becomes negative, okay, plus 3 equals b to the power 30 minus 2, 28 plus 3 equals b to the power 31. I hope you got it. The next example we have 2 to the power 3 multiply 2 multiply 2 multiply 2 to the power 3 multiply 2 to the power negative 5. How you should do it? You shouldn't have to make this portion like 2 to the power 2. Can't we? Of course we can. So we're going to write 2 to the power 2. Then we have the same base if you think. 2, 2, 2, 2, of course. So we're having here 2 to the power 3. This portion, I wrote it like 2 to the power 2. Multiply 2 to the power 3, multiply 2 to the negative 5. Equals, we're having just and only the same base, okay? 2. Adding up the exponents, 2, 3 plus 2 plus 3 negative 2 becomes 2 to the power 3 plus 2, 5 plus 3, 8, 8 minus 5, okay? Becomes 2 to the power 3. 2 to the power 3 equals 8. 2 to the power 3 means 2, 2, 2. 2 into 2, 4. 4 into 2, 8. I hope you got it. So let's do some more examples. So let's do these two examples. How would you do it? Think about it. The first rule, okay? We're having the same base, AB, AB, AB. In case of multiplication, this is just for multiplication, okay? Not for addition, not for subtraction. We will talk about them later, okay? I'll explain everything, a single thing for you. So what we should do is just and only take the common base, which is AB. What should you do the next thing? That is to add the exponent. Negative 20 plus 15 plus 6 equals AB whole to the power negative 20 plus it becomes plus positive 15 plus 6 becomes 21. So it equals AB 21 minus 20 becomes 1. We're having the symbol or the sign of the greater number, which is 21, which is positive, okay? Positive 1. So how would you do it? Of course, it is fully, completely simplified. The answer is AB whole to the power 1 becomes AB. This is our final answer. I hope you got it. Try to do it by your own as well. So what should you do for the next question? 1, 2, 3. We're having 3 bases, but the same base. 2AB here, 2AB here, 2AB here. So taking 2AB. What you should do, the same as here in the above examples we did for. So minus 5 plus 20 minus 100 equals 2AB whole to the power. If we have numbers with the same symbols, we should add them together, okay? Negative 100, negative 5. What you should do, we should add up them. So becomes negative 105 plus 20. If we have the numbers with different symbols or different signs, we should subtract them. 2AB having different signs, okay? This is positive, this is negative. And we should subtract them and take in the symbol of the greater number. What is greater number? 105 becomes negative. 105 minus 20. 5, 7, okay? 75. This is our final answer. 2AB whole to the power negative 75. Or we could write this number as 1 over 2AB whole to the positive 75. We will talk about them later, how to make the negative power to positive. We will explain them later, step over step. Here I have written examples, 2 examples. But what do you think? How would you solve it? Can we apply the first rule? Of course, we can't. We cannot apply the first rule over it. If we apply, then we made a mistake, a greater mistake. Because we have addition here, okay? Addition, subtraction. And the first rule can't be applied over it. If you apply, let's do it, okay? If you apply, we're having the same base, okay? 2 to the power 7. 2 to the power 7 becomes, I think, 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 2. 2 to 4, 4 to 16, 8, 8 to 16, 16, 34, 32, 64, 64 into 2, 128. Okay? If you apply the first rule, its answer is 128. But this is completely wrong. Why? Because the first rule can't be applied here because we have here the symbol of addition. But the first rule is just for multiplication, just for products, okay? So how would you solve? Just simplify each of them, then add them together. 2 to the power 3. 2 to the power 3 equals 8 plus 2 to the power 4 equals 16. So its answer is 24. 128, 24. How much bigger difference we have. The next question is the same as that. Just simplify, then add and subtract. 5 to the power 3 becomes 125. 5 to the power 3. 5, 5, 25, 5 to 5, 125, okay? 125 plus 5 squared becomes 25 minus 5. 5 to the power 1, okay, equals 5. So 125 plus 25 equals 150 minus 5 equals 145. But if you solve like this, 5, 2 plus 3, 5 plus 6, 5 to the power 6 becomes a much more bigger number. Let's do it. 5 to the power 3 becomes 125 multiplied by 5, multiplied by 5, multiplied by 5. It becomes more than 5,000. But the answer is just and only 145. I hope you got this lesson, okay? Try to do more examples as much as you can, but if you have any question, you can share your question in the comment section below. I will be here to answer to your question as soon as I can. You should do one more thing as well, that is to subscribe to my channel, hit the bell icon, okay, until you receive all of my new videos I'm sharing with you. And also, if you want to improve your chemistry, of course I have a teacher, you could check that out. He's teaching chemistry and is an expert in chemistry. Of course you can learn chemistry with that guy, and you can also learn English grammar with me along with mathematics. Well, thank you for your being with me. I will see you in the next coming video. Bye for now.